Assalamu alaikum warahmatullahi wabarakatuh. This is Dr. Ali El-Moursy, and we are in the Digital Logic Design DLD classes. We are in lecture number 28, part 1. Now we are starting a new chapter, chapter number 6. Chapter number 6 is talking about applications for DLD, for sequential circuits. Applications for synchronous sequential circuits. Two applications we will cover in chapter 6. The first application is lecture 28, part 1 and part 2, which is called the counters. The counters. We need to see mature, useful applications for synchronous sequential circuits. The application that we will cover today is called the counters. Counters. What is a counter? Counter is a circuit that counts. We have plenty of types of counters in our real life. Counters is a circuit that is actually supposed to go from one number to the next, okay, in a sequence, in some pattern of sequence. We will actually cover different types of counters throughout this lecture. However, we want first to discuss, is the counter circuit should be a sequential circuit? The answer is definitely yes. Not because we are teaching it in chapter 6, but because actually counters, if I have a counter and I want to count, this counter may have the first count is simply the count 0. And through some excitation, I need this counter to go advance from one count to the next. Okay, so the counter will go from 0, the next count will be 1, then the second count will be from 1, he will go to 2, and then from 2 it will go to 3, and so on. So this is a counter. Is a counter a sequential circuit? Definitely yes. Why? Because I need a memory. Because I wanted to memorize to know what was my previous count in order to assign or to know the next count. So the counter circuits are synchronous sequential circuits because I want to know the history, and from the history I will predict or I will evaluate or find the future. Counters are classified or are defined or are characterized by 4 factors. If you understand those factors very well, if you answer the 4 questions about the counter, that means the counter circuit will be very easy. Definitely, and since it is a synchronous sequential circuit, we will start by in order to design a counter, I will start by a state diagram. So if I successfully build the state diagram for the counter, that means I can easily, from the state diagram, go to the state table and then the K-maps state equations and then the circuit. So I can develop my counter very easily. So our first point today to discuss are the 4 characteristics of any counter. Counters has 4 characteristics or 4 things that we need to answer, 4 questions to ask ourselves. And the first thing that define the counter is the direction of counting. Direction of counting. In the direction of counting, we have different types of counters. The counter could count up, like the one that we just count From count 0, I go to count 1. From count 1, I go to count 2. From count 3, I go to count 4, and so on. So the counter may count up, may count down, may count in both directions. I have a counter maybe counting up or down. An example, we all go to the mall. We all go to the parking lot of the mall. Okay? When you go to the mall, you will find a display to count the number of cars in each floor. This is a counter. This counter, is it counting up or counting down or counting both directions? It should count in both directions. When a car enters the parking lot, the counter will go up. When a car leave the parking lot, it should go down. So this is an example of a counter that counts in both directions. Okay. Another example, al-masbaha, the self-counting masbaha. Okay. This is a counter up. Okay. So when you click on the button in your finger, okay, that you actually stick to your finger, okay, it keeps counting up until it reaches to some value, and then you may press on reset to send it back to the 0 or something like that. Okay, a counter that counts for people who are in a race. When you start setting some value, so you won't have a stopwatch. The stopwatch, okay, so you maybe fix the stopwatch to 60 seconds, and you trigger the counter to start counting. So the counter will keep counting down until it reaches 0. When it reaches 0, something will fire, or some alarm will goes on, or something like that. So this is an example of a counter that counts down. Okay, the first thing, the first characteristic about the counter is the direction of counting. It's either up, down, or in both directions. The second characteristic of a counter is the range of counting. The counter should have range of counter. When I'm designing a counter, I should know what are the limits of counting. Okay, so is it a counter that counts from 0 till 100, from whatever, from it counts from whatever, from 60, if I'm counting down seconds or for a stopwatch. So I started with 60, go down to 0. Okay, so I want to know the range of counting. If I know the range of counting, that means I can design the counter. يبقى the second thing is the range of counting. In the range of counting, we have actually kind of standards for the counters. Okay, we can classify 3 types of counters based on the counter range. We have what's called the binary counter. The binary counter. Okay, what's the binary counter? Binary counter, the counter that counts in the range of binary. What's the range of binary? Range of binary is powers of 2. Yeah, 2 to the power n, power of 2. So that means binary counter could count. If I have 1 bit, that means I have how many counts? I have 2 counts, 0 and 1. If I have 3 bits, 1 bit, 2 count. If I have 2 bits, 2 bits means I have 4 combinations. I have 4 counts, 0, 1, 2, 3. Okay. If I have 3-bit counter, okay, in the binary range, this will count from 0 till 7. Okay. So a range of counting could be binary. Okay. Could be what's called the BCD counter. What's BCD counter? BCD counter stands for binary coded decimal. What's binary coded decimal? Binary coded decimal is that the counter itself is binary counter. We are only developing a binary circuit. but it is designed to count in the range of decimal. Range of decimal. What's the range of decimal? The range of decimal are the values from 0 till 9. This is the range of decimal. This is called the BCD counter. The other type, or the third type of counters, is arbitrary. Arbitrary. That means it counts in any range, okay? Whatever the range is. Fine. Can we take some examples of a BCD counter? Yes. Do you know this? Now, since we are talking about the counters, let's take a real examples of a counters. What is this? What is the Dr. Ali have just drawn here? Yes, this is called what? This is called the digital clock. This is called a digital clock. I have in the digital clock, how many counters? I have in the digital clock here, I have 6 different counters. Or you can say that they are, if you are taking this as a counter, that means you have 3 counters. Count for the seconds, counts for the minutes, counter for the hours. However, it's easier to even split it more and deal with each of those digits as a separate counter. By the way, both designs are correct, but each of those designs has pros and cons. But anyway, I have here a counters, okay? Now, where can we identify a BCD counter? Which of those is a BCD counter? The BCD counter is the first digit here in the seconds. Why? Because the counter here should count starting from the value 0 until it goes to 9 and then goes back to 0. So I have here BCD counter. Agree? Right. If I deal with this as a separate counter, what is the range of counting for the second digit here? The second digit in my digital clock, is this a BCD? Is this binary? No. So let's go to the range of counting. The second digit here counts from 0 till 5. From 0 till 5, and then it goes back to 0. This is arbitrary counter. First one is BCD. The second one is arbitrary counter. The third one, this is also BCD. This is also arbitrary, counting from 0 till 5 and go back to 0. This is from 0 till 9. Okay? Agree? Make sense? Right. If I'm using a 12 hours clock, okay? What is this counter? This counter is actually a mix, but the maximum value for this counter, if I'm counting 12 hours, so 12 hours, this will go from 0 till 9 and then go back to 0. And so this is also a BCD, but it's not a straight BCD, because when this has the value 1, okay, this counts only between the values 0 or 1, okay? So this is also this counter is counting 0 and 1 and go back to 1. But this is another arbitrary counter. So agree? Make sense? Here we discuss the digital clock, and we can see different flavors of counters. Okay? The most important thing that we have to know is that counters are defined by their range of counting. This is the second factor. The third factor for the counters is the direction of counting, the range of counting, and the sequence of counting. What does it mean by sequence of counting? These are linear counters. That means from 0 I go to 1, from 1 I go to 2, from 2 I go to 3, and so on. No matter what's the range, I may reach to some limit and go back to 0, but they are all kind of linear counters. Okay, if I have sequential or linear counter, sequential counter, and I may have a hopping or jumping counter. Examples for sequential counters are all the counters for the digital clock. Also, the counter that I have in my parking lot. Okay, I don't want when a car enters, the counter will count 2. Okay, it always goes sequentially from one count to the next, either up or down. Okay, so it's counting one by one, either up or down. يبقى ده ايه؟ Sequential counter. Okay, we may have also a hopping counter. I may design a counter that counts, okay, in twos. So means count 0, 2, 4, 8, 6, 8, and so on. So skipping the odd numbers. This could be a counter. Or I may design a counter that counts in fives. Okay, so count 0, 5, 10, 15, and so on. Or count in hundreds, or count in thousands, or counting every 10 or every 20. Okay, so the counter could be sequential or could be hopping counter. But this is the third characteristic for a counter. The fourth characteristic for a counter is the trigger of counting. Trigger of counting. This is very important feature about the counter. The trigger of counting. What's the trigger of counting? Trigger of counting means what is the excitation for the counter to count. Examples: parking lot. The counter in the parking lot. What is the excitation for counting the counter of the parking lot? It is an external trigger. What is this external? When the car passes through the infrared at the entrance of the parking lot, the counter will be excited to count up. When another car at the exit passes through the infrared, this will excite the counter to count down. يبقى counting up or down here for this double direction counter for the parking lot is the excitation is external. We have here two types of counters. I have what's called the external trigger. External triggered counters, or what we have the self-triggered counter. It's either external triggered or self-triggered. What does it mean by self-triggered? Self-triggered means the counter is counting without external trigger. It's self-excited. Example, here is it. This counter. Who tells this counter for in my digital clock to go from count 5 or from count 2 to count 3 to count 4 to count 5? Okay, it's self-triggered. There is no excitation. Only the clock of the circuit drives or forces the counter to go from one count to the next. We call this a self-triggered counter. Okay, parking lot is not self-triggered, it's external triggered. This counter is self-triggered. Okay, the counter in the parking lot is external triggered. Also, the counter for masbaha, when you put this counter to count to Soul, subhanallah, okay, is this self-triggered or external triggered? It is external trigger. When you press the button, it goes from one count to the next. This is another example for an external triggered count. Now let's define the counters here. If I am assuming that I have 6 counters here, what's the excitation for each of those counters? Okay, there are 2 ways to design those counters. I can call that all of those counters are self-triggered. Okay, so this counter is counting every clock. This is a synchronous sequential circuit, so it's connected to the clock. So I am driving the circuit to excite it from one clock to A or from one count to the next. Okay, so I can design all of those 6 counters using what? Using self-triggered counters. I can use a self-triggered counters for all of them. However, the clock is the difference. Okay, the clock is what makes the difference. This is let me just put the label here. This is the digital clock. So what will make each of those count differently than the other is the clock. So the clock for the first should count every one second. Every second this counter should count. What about the second digit here in the seconds? Every 10 seconds this counter should count. What about this? Every 1 minute. This one every 10 minutes. This counter every 1 hour. This counter every 10 hours. Okay, here I can design all of my digital clock using a self-triggered counting. Another design for the digital clock is to use only the self-triggered for the seconds and make the seconds drive the second digit of the second. So when this counter goes from it counts from 0 till 9. When it goes from 9 to 0, it will send a trigger to this counter to count. Okay, so if this is originally 3, when this goes from 9 to 0, this will go to 4. So this will be driven by the transition of the first one from 9 to 0. Okay, so this could be an external trigger for the transition of the first one from 9 to 0. And the same thing for the second. When this also goes from 0 till 5. And when it goes from 5 to 0, it will send a trigger for the minutes to count, and so on. So each of those counters could drive the next one to count, okay, for a specific transition. If a transition from one count to the next will make the counters to count. Agree? So now we understand the counters in general, the general concept of the counters, the 4 questions that we need to answer about the counters. If you have an answer for the 4 questions, so you can design any counter ever. And this is actually the first part of our lecture. Okay, now let us go ahead and design one of those counters. Okay, this what we will be learning inshallah in the second part of our lecture. Okay, so in the first part we covered the counters in general and the 4 questions, and in next lecture, in the second part of lecture number 28, we will design binary counter, 3-bit binary counter. We may take a couple of examples for the counters in the second part of this lecture. Okay, so we will stop here at part 1 of the lecture number 28. In the second part, we will go and design the state diagram for some of those counters, and we will even take one of them as an example, and we will do the design in full till the end of the circuit until we reach a circuit for a counter. Okay, see you inshallah in part 2 of our lecture number 28 inshallah.